I am Rajdeep Udane.
We have studied the chemistry net state gate examination. In the private house of group A, we will study about firstly symmetry, symmetry elements and symmetry operations in first of the lecture. We will study in second of the lecture, series of lecture. The second lecture will be delivered with many of symmetries. MLL, molecule with a lower symmetry. MHS, molecule with a higher symmetry. And last third one, molecule with a HS, higher third, molecule with a special symmetry. Then, in group A, we only study about symmetry. The particle or physically entangled, though are fascinating in nature called example cube, triangle, square, pentagon, pentagon, hexagon, then symmetry element, though have the symmetry which are described by identity, that should be denoted by E. The molecule has Cn of n rotation is equivalent to 360 degree. That should be defined as identity of molecule. Then second, axis of rotation. In axis of rotation, there are presence of Cn, principal axis Cn, as well as subsidiary axis of rotation other than principal axis. Third, plane of symmetry. The molecule must be contain three types of plane: vertical plane denoted by sigma v, horizontal plane denoted by sigma h, and dihedral plane denoted by sigma d. Next, improper axis of rotation, that should be identified by Sn element. These are identity, these are axis of rotation Cn, these are plane of symmetry, these are Sn, improper axis of rotation, that should be equivalent to rotation and reflection phenomena. Then fifth number is an center of axis of rotation, that should be denoted by I. Then we will confine this all of the symmetry element with the symmetry operation. But we will find out how group theory will be prolonged. Group theory is starting from the E. Galois is a scientist who find out the symmetry of an element. And in last one, Mary Gell-Mann in 1969 awarded by Nobel Prize for this symmetry of particle. Then the mathematical study of symmetry, it's called group theory. It's called as group theory. In case of symmetry operations, symmetry element with respect of symmetry operations are concerned as symmetry operations are the symmetry are deviated or new geometrical changes are accompanying called as symmetry operation. Example: rotation, reflections, or center of axis of rotation. We will be confined in symmetry operation to the symmetry element. The first one, the molecule has symmetry element with respect to symmetry operations. Symmetry elements are with the symmetry operations. Symmetry elements are identity. There are Cn of n axis, that should be 360 degree of rotation. No other structure will be provided here. No other structure provide. So molecule must be present as identity. Every molecule must be present of identity. Then second one, axis of rotation. First, principal axis, that are Cn. In example 2, if it is 2, then angle should be 180 degree. If it is 3, then angle should be 120 degree. If it is 4, angle should be 90 degree. Those are confined. Cn of 360 divided by 2 is equal to 180. Then Cn C3 is equal to 360 divided by 120. Then 120. Then C4 360 divided by 90 is equal to 4. Is equal to 90 degree of rotation. Then subsidiary axis. Other than that, subsidiary axis, the molecule which have present other than principal axis of rotation, in which if it is principal axis is C3, the molecule must be presence of C2, subsidiary axis of rotation. Then third, plane of symmetry in which there are three planes. Vertical plane act as a mirror image. Those are confined are denoted by sigma v plane. That should be mean as a reflection phenomena. Reflection. Then second, horizontal plane. That should be mean as water image, as presented denoted by sigma h. Horizontal reflection equivalence. Then C, dihedral plane. There should be presence of dihedral image or angle in between them. So denoted by sigma d, dihedral reflection equivalence. Then we will study about all of this symmetry element can be considered as a improper axis of rotation. Improper axis of rotation. Improper axis of rotation. That should be denoted by Sn, and phenomena as rotation as well as reflection will be to understood. We will compare. If it is S2, then rotation should be S2 of 1 into reflection of sigma V1, C2 of 2 into sigma 2 is equivalent to their rotation reflection axis. Fifth one, center of axis of rotation. Center of axis of rotation. The molecule must be present an identity that will be denoted by I. If the center of molecule has substituted in equal distance called as center of axis of rotation. On example criteria, if the molecule should be in identity, just like NH3, present an identity of the molecule, then axis of rotation, the molecule N3 must be possess a C3 rotation. In case of substituting axis, the molecule must be passed a 3 patterns of substitution axis C2 and C2. Then these are the 3 C2 of plane of symmetry. Otherwise, we will discuss about the NH3 molecule. These have 3 C2 axes are present. Approximately 3 sigma V1, sigma V2, sigma V3 planes are present. Then there will be absent of horizontal plane. There will be absent of dihedral plane due to the presence of symmetry of NH3 molecule. Then last one, improper axis of rotation. The molecule could not be present imperfection in that material, but will confine with the horizontal plane. The molecule just like benzene. These all are the element in the uniform and planarity. There will be presence of sigma H molecule. That will be plane of symmetry, horizontal plane. In case of dihedral plane, the molecule should be arranged of allele in dihedral case. Volume should be arranged in cubic geometric format. Firstly, the element carbon, double bond carbon, double bond carbon are arranged H, H. Then the another element should be arranged at this H and at this H. So presence of diagonal plane passing from the entity, presence of diagonal plane passing from the entirety. This one acts as a diagonal plane, and those hydrogen present in up and down phase act as dihedral angle in between plane and this substitution element is 90 degree. Then we will be studying about improper axis of rotation. If any material that should be presence of this type of structure, just like benzene should be presence of improper axis of rotation. We will study about even and odd system. In case of even system, we will be deliberate new changes, just like then those are presence of principally should be Cn equal to C6, which should be presence of S6 or symmetry element. Then center of axis of rotation, so benzene are presence of identity due to presence of same element in same vertical format. The center has equal distance with the deliberating material, equal distance, equal distance, equal distance and equal distance. If it is around equal distance, then presence of symmetry. Then point group are the fitting phenomena find out by the symmetry of element. Those symmetry of element are classified as identity. Each and every compound presents an identity of molecule. That is Cn, n number of rotation will be present. That should be 360 degree. Then second, axis of rotation are confined by principal axis of rotation. Principal axis of rotation. Just like if it is placed of C3, then subsidiary axis of rotation are C2. These are calculated by Cn n minus 1 character, that is C3 of 3, C3 of 2, C3 of 1. This C3 of 3 act as an identity, placing this order, and remaining 3 C2, C3 of 2 and C3 of 1 are new one identical operation. Then subsidiary molecule are present of C2 symmetry. Then third one, plane of symmetry. Plane of symmetry are presence of three types of plane: vertical plane, denoted by sigma p, horizontal plane denoted by sigma h, dihedral plane are denoted by sigma d. The sigma p are the vertical plane passing the mirror image. Those are water images. And those are vertical plane. with dihedral element in between them act as a dihedral plane. Then n number of C2s are equivalent to sigma p plane. The molecule have sigma h in even symmetries of molecule dihedral plane. The sum of the molecule in the priority of plane plus front plus back are act as plane and front and back act as a dihedral plane. The improper excess of rotation. Improper excess of rotation. Improper excess of rotation are equivalent for firstly rotation and reflection. Rotation are present according to principal axis. Principal axis. Even and odd. If it is even, that should be denoted by Sn probability. If it is even, Cn of n representation that are contained by two parent elements, Sn of n, Sn of n by 2, n. So if the values of n equal to 2, then S2 of 1 to 2 and S of 1 to 1. Then n equal to 4, S4 1 to 4, then is equivalent to S2 1 to 2. Then n equal to 6. Then n equal to 6. S6 of 1 to 6 or S3 of 1 to 3. Then n equal to 8. S8 of 1 to 8 is equal to S4 of 1 to 4. Then in case of odd axis of rotation, odd are Sn of twice n. Then we will define odd values if for n equal to 3, then those are deliberately divided into S3 of 1 to 6. Then n equal to 5, then equivalent to S5 1 to 10. n equal to 7, S7 1 to 14. n equal to 9, S9 1 to 18. Axis of rotation. In case of reflection, reflection are possible for odd plane and even plane defined by principal axis. Odd plane and even plane. If principal axis is odd and even, then sigma is equal to sigma 1. Sigma into sigma is equal to identity. Sigma into sigma into sigma. Identity into sigma is equal to sigma. If it is even formalities, sigma 2 is equivalent to sigma into sigma is equal to identity. Then in case of sigma 3 is equal to sigma into sigma into sigma, identity into sigma is equal to sigma. For any odd rotation, n equal to odd, then equal to sigma. If any sigma is equivalent to even, that should be identity. Sigma n equal to even, then it should be identity. Then last one, center of axis of rotation. Center of axis of rotation. Center of axis of rotation is denoted by R. this is denoted by R. Any symmetry element, just like molecule are square planar, molecule are octahedral, molecule are hexagon, are presence of asymmetry, just like square planar complex Ni CN4 diagonally are presence of asymmetry. That means those molecules are equivalently present of asymmetry with the central distance. From this metal to this ligand, from this metal to ligand, from this metal to ligand, from this metal to ligand have equal distance, equal distance, equal distance, equal distance, equal distance. Hence presence of asymmetry. In presence of asymmetry. These are I equivalent to S2. These are I equivalent to S2.